Thanks for tuning in to the Lean 911 podcast, where you'll have a voice directly from the Gemba. I will rely on my 3 decades of Lean successes as well as my failures to answer your most challenging questions regarding your Lean transformation. I'm your host, Mark DeLuzio, President and CEO of Lean Horizons Consulting and the Principal Architect of the Danaher Business System. Looking forward to your questions. Now, let's go to the Gemba. Mark DeLuzio, episode 64, Lean 911 podcast. This is the 9th episode I've had on problem solving. If you go back and look throughout all the different, various episodes that we've had in the past, and this is episode 64, 9 of those 64 episodes are about problem solving. And this is the 9th one. And this episode is going to be talking about critical thinking. And the question really is, are you a critical thinker? Everybody thinks they are. Everybody thinks everybody else doesn't have common sense but them. Everybody thinks they're critical thinkers, nobody else is. I want to go through some of the mindsets you have to be a critical thinker. Now, I think what you'll probably find is you might have all of these or you might have some of these. I doubt anybody would have none of these, okay? But these are the mindsets of a critical thinker that you have to develop this skill. And as a lean professional, you actually have to develop the skill set in the people that you're training. In order for an organization to be a great company, you need to know how to solve problems. And I don't care if that has to do with lean, daily management, Hoshin Conry, or strategy deployment. It doesn't matter. You need to be really good problem solvers. And you need to be critical thinkers. And as a leader of the problem solving process, when you're facilitating any kind of Kaizen, because to me, a Kaizen, quite frankly, is a problem solving activity, you need to be a critical thinker with this mindset. And I'm going to go through some of the things that you're going to need to know in order to be a good critical thinker. Okay? The first thing I want to stress is what Deming talked to us about way back when, that it's easy to indict the person. When there's a problem, it's easy to say, hey, look, who did it? Who messed up? Bring that person in here. Let's write that person up. Okay. I was actually talking to a colleague the other day, and one of their prior bosses had this, or actually the guy was on a job interview, and the guy who was interviewing them said, yeah, this job's open. I had to write this guy up a number of times, and now he's out of here. What do you mean write him up? What does that even mean, to write him up? Okay. But this person obviously was indicting the person, not the process. Deming said 94% of problems are systems problems, or in other words, process problems, not people problems. And I think you probably argue most people come to work, they don't want to do a bad job, right? So here's just a little example of a dialogue. Let's say there's an error. I can approach Joe, who's, overseeing this process, 2 different ways. One, hey, Joe, how could you make this mistake? How long have you been working here? Don't you know what you are doing? What's going on, Joe? Come on, man. You got to get better than that. Okay, now look, what's Joe going to do in this case? He's going to become very defensive, probably start thinking about writing his resume because his boss is mad at him, right? Or I could take this approach. Hey, Joe, let's find out together what went wrong with this process. Given your experience, I really love your insight and your thoughts on this issue. And by the way, we're not going to let this process do this to us again. All of a sudden, you shifted the weight off of Joe's shoulders. He probably feels a little guilty anyway, to the process. Remember, it's our job as leaders to provide winning processes. And I'll talk more about this later. And by the way, you're going to hear me talk a lot about Deming throughout this presentation. Okay, he'll come up a number of times. So the first thing, and this is the most important thing, I think, do not indict the person. You want that person to be working in a blameless environment, in and still to be able to come back to you and give ideas and not feel like they're going to be persecuted if there's a problem. Okay, you want people to be able to raise problems so they can be solved without threat of retribution, losing their job, or whatever. Okay, all right. Finding the problem is the most important part of the problem solving process. Okay, now this is a mindset issue. I know I've done it. How many times have you launched into a problem, feeling compelled that you have to take action as a leader or as a continuous improvement person, whoever, and found out you didn't define the problem very well, and all you did is waste everybody's time, probably created 3 more problems, all right? So, ill-defined problems are probably the biggest problem in problem solving, all right? Where problem solving efforts go wrong. And Albert Einstein said, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. Okay? Pretty powerful if you think about it. Are we really working on the right problem? I'll bet you anybody out here who's listening to this had issues before where the problem was ill conceived and we just went down the wrong track, right? If you're not watching on YouTube or Rumble, you're going to see a guy there's a boat here. He's got a leak in the boat and he's bailing out the boat, but he's not addressing the problem, which is the leak or the hole in the boat. But he's also bailing the water back into the boat. So, okay, so not only is the problem ill defined, so solution is ill defined as well. Okay, so defining the problem, I cannot stress enough. I was just with a team today, virtually. They're international, and we spent all 2 hours talking about the problem and the data that goes into it. And I'll talk about this in a minute. And by the way, we did not even get to the problem statement yet. Okay. This is the most important part of problem solving. You may think you're wasting your time because you're not getting anything done. No, it's well invested in doing so. Okay. As a problem solver, as a critical thinker, question everything. Do not accept any excuses. Do not accept any data unless you can verify it. Ronald Reagan once said, trust but verify. He said, yeah, I'm going to trust you, but I'm going to verify what you're telling me. Okay. This had to do with the Soviet Union when they said, do you trust the Soviet Union? Yes, I trust them, but verify. Right. My sensei Nakao told me, DeLuzio son, do not listen to them. They will only lie to you. He's pretty direct. Your eyes will not lie. Go see. Go to Gemba. Okay. Go to Gemba. That was Nakao. Do not listen to them. Go find out for yourself. All right. The common excuses that you get all the time, and I know you've gotten them, I've gotten them. We've got to do it this way because the customer requires it. Yeah, show me the spec, show me the requirement. 9 times out of 10, there is none. Okay. Or maybe it was tribal knowledge told to them from something that happened 10 years ago. It's industry standard. That's the other one that comes up. I love that one. Show me the standard. It's government policy. The government forces us to do it this way. Okay, show me the regulation. And I have a note in here that says, beware of the 8-hour syndrome. So, how many times have you heard things like curing time, burn in time, um, whatever? Always divisible by 8 hours. Yeah, that's the cure for 24 hours. Or it has the cure for 16 or 48. I once had a blow molded product. I was told that had a cure for 48 hours. And when I challenged them, I said, can it cure for 47? Yeah, that should be okay. All right, how about 46? I said, look, I'm not going to stop until you tell me to stop. Turned out to be, after they studied it, and I forced him to go look at it. It turned out to be 20 minutes of cure time, not 48 hours. Okay. So challenge everything. Do not accept a thing unless you've got validation. Remember, you're a detective. When you're problem solving, you have to have a questioning, curious mindset, just like Sherlock Holmes. If you're in the United States, you'll probably remember, if you're old enough to remember the detective show Columbo, he would just go around and ask questions. And as he's collecting the answers to these questions, in his mind, he's kind of playing them off each other. Wait a minute, this guy said black, but that's really white. That doesn't make sense. And at the end of the show, of course, at the 59th minute of the show, he'd solve the case by asking one key question, right? So question everything, okay? Do not accept things and take everything that's told to you as truth, all right? Seek diverse views. As a critical thinker and a problem solver, do not just associate your people who are familiar with the process. A problem is rarely solved by a single function. If it's an engineering problem, engineers most likely won't solve the problem. You need to bring in other functions, other diverse views, and by the way, bring people in that know nothing about the problem. You might be surprised the questions they ask and the observations that they make are astounding. This happened to me when I solved a problem at one of our divisions in England. All the engineers got together for this test stand problem that they had, and they couldn't solve it. So I was asked to come over and help them. I said, "Have you involved the operators?" No, what do they know? They only put the product together. That's what I was told. The arrogance, the elitism, if you will, right? So I got the operators together and other people as well from the company, from other functions. And as I'm going through, it's actually a process called CDEC, cause and effect diagram with the addition of cards. One of the operators made this observation: the problem only happens on the weekend. I'm sorry, the problem doesn't happen on the weekend. Okay, that really hit me. I said, okay, what's going on here, right? Come to find out, there was electronic magnetic interference from the plant next door during the week, intermittently, that interfered with our test stand unit. But that company didn't work on the weekends, and we did. So through a lot of questioning, we found out what the problem was. So we took, you know, the countermeasure was to protect our equipment with a shield that would protect itself from EMI. Okay. The operator came up with that. The engineers didn't think it was worthy. They were worthy to be asked their opinion. And all the guys said, "Yeah, hey, we don't get this problem on the weekend." Wow. I had to fly all the way to England. Now it was Brighton, England. It's a very nice place. It's where the Queen used to vacation. um, I didn't mind going to England. I love England, but a lot of money wasted because we just didn't know how to solve problems. Okay. Do not think a single function is going to solve your problem. Very rarely is that going to happen. Okay. Here's our friend Deming again. You cannot solve a problem that you can't understand. You probably heard this saying before: in God we trust, all others bring data. Okay. You can't solve a problem you don't understand. What is the data telling you? If you're not watching, I've got a bunch of Paretos sitting on this chart. One says shift, one says operator, one says product, one says machine. Okay. What are these Paretos telling you? What is the data telling you? There's an incredible amount of data collection that needs to happen before you develop a problem statement. Okay. And I'm not going to get into the mechanics of developing a problem statement on this particular episode, but you have to collect a lot of data first to understand who, what, when, where, why, all that, right? So collecting data is key. And by the way, I am partial to the Pareto diagram. It's so effective, easy to understand, but sometimes hard to use if you don't know how to interpret it. Okay, the root cause of a problem is really resides where the problem is found. Now, remember, as a facilitator of the problem solving process, you have to have these concepts in mind. Okay. When you see a problem happening at a particular operation, for example, it may not occur, the root cause may not be from that point of discovery. Okay. So a lot of times we use the 5 why analysis. You probably heard of that before. And I got a simple example here. Okay. To maybe track where is this problem coming from. So let's say our initial assumption operators at the final station are believed to be assembling the parts incorrectly. Okay, so the first question I'm going to ask in the 5 whys are, why are the finished products misaligned? The answer is because the components are not fitting together properly. Okay, the second question, why are the components not fitting? The answer is because the holes for the fasteners are slightly off center. Third question, why are the holes off center? The answer is because they were drilled inaccurately. Okay. Fourth question, why were they drilled inaccurately? Because the fixture used in the machining process was worn out. Fifth question, why was the worn fixture still in use? And the answer was because preventive maintenance for machining was not followed for these fixtures. Okay. So here's a case where I can go up to the operator, going back on indicting the operator versus the process. Hey, why are you guys screwing up? Why aren't you making your production? Why are you struggling with putting this together? Didn't we train you on how to put these parts together? Where the problem resonated all the way from the machining area where preventive maintenance was not being followed. Okay, that's the root cause. All right, which obviously led to the worn out fixture, which was incorrect drilling of the holes and all that. So here's a case where the 5 why can help you sort of go right back to find out where the real root cause of the problem is. And again, indict the process. I wouldn't go into the preventive maintenance area now and say, hey guys, what the heck's wrong with you guys? What's going on, man? Why weren't the why were you allowing these guys to use a worn out fixture? And why wasn't preventive maintenance done? I would say, show me your preventive maintenance program. Show me how these fixtures are part of that. We have an issue here. We need to look at this and get this process back up and running. Okay. This is a process problem that we need to look at. All right. And on other episodes, I talked about the different types of process. Whether I have a standard or not is a type 0 process if I don't have a standard or a process. A type 1 is I do have a process, but it's not being followed. And I need to find out why and, modify the process if needed. And a type 2 problem is I have a process, it's being followed, but it's not giving me the desired results. Okay. Correlation does not automatically equal causation. I've seen this mistake so many times in business. Well, I have data that supports my paradigm as to why I think we have a problem. So I have a very simple example here. And you don't want to jump to conclusions here. Again, you want to always question and challenge and keep saying, what else could have caused this problem? But my hypothesis is all auto accidents last year involved cars with black tires. So I'm going to conclude that to avoid accidents, don't drive cars with black tires. Foolish, right? It's a foolish example just to accentuate a point. But you see this all the time. You see this all the time. You see it in the news. You see it in newsprint. Maybe an article that says scientists have discovered that eating yogurt, people who eat yogurt live 5 years longer than those people who don't. Okay. What they're not telling you maybe is, wait a minute, the people who eat yogurt don't smoke, they don't drink, they exercise. Okay. So if you're 500 pounds and you sit there and say, geez, I'm going to go start eating yogurt, I'll live 5 years longer. No, it's not going to happen. Right. So you have to look at this in context. So just because there's a correlation to a causation doesn't mean there's a direct association with it. Correlation does not automatically equal causation. No, you can drive a car with white tires and still have the same risk of an accident than a car with black tires. Okay, so think this through when you start looking at data and you think you found the answer. You always have to ask yourself, as a critical thinker, what else could it be? Especially if you believe in the adage we just talked about that there's usually more than one cause to a particular problem. Okay. Oh, here we are. Sorry, I jumped the gun. Here's a slide on that. No significant problem is the result of a single root cause. There's usually more than one root cause to a problem. Now, sometimes this is a result of just defining the problem too broadly, okay, as opposed to narrowing down to a very specific part of the problem, all right? But you have to be comfortable as a problem solver and a critical thinker. You have to be comfortable with being uncomfortable. Keep an open mind to other potential root causes. And don't just feel comfortable with the one you found, because most likely there's something else that's going to rear its ugly head. So let's say I got a high scrap rate. Okay. I could have three root causes to this. One, I could have a misaligned die set, worn out alignment pin, and the preventive maintenance was skipped. I also could have another problem with a high scrap rate. The incoming material was not to spec. Okay. And maybe the supplier changed the spec without following the procedure to inform us. Or another root cause could be operator bypassed the QC check. So temporary operator ignored the alarm for out of spec conditions, and there's a lack of QC work standards. Maybe we didn't. Maybe our onboarding process for a new operator wasn't followed, or didn't have one at all. All three of these simultaneously could be contributing to the high scrap rate. All three of these, all at the same time. So you may find, oh, geez, I got the answer. Misaligned die set. Got it. Fix that. Let's get the die set all aligned. Fix that. Put the process in place and all that. But still have these other two out there that are still going to cause you scrap. Okay. So be careful. Just be careful that you don't just settle on one root cause. Always think that most likely there's another one out there somewhere that's going to, again, rear its ugly little head. Right. Going back to the adage that where you find the problem may not be exactly where the problem root cause exists. So many times we aren't looking at the input. So I'm showing on the screen right now, for those of you not looking on the video, input, process, and output. Okay, your inputs could be raw materials, could be labor, energy, specifications, temperature, information, pressure, whatever. Your process could be your machining, assembly, testing, design, printing, plating, heat treat. By the way, these are all manufacturing processes. Same thing happens in administration. Okay. How many times you get a bad finance report because of bad inputs, right? And the output could be your finished product, your defects, your scrap, your rework, your downtime, right? That's your output. So if you're not looking at the inputs, you may be making a big mistake. Now, I've got an example on this slide. It shows a defective cake. That cake is sitting there with cracks in it, a big crater in the middle. Okay. The input to that cake was all the ingredients. So you got, butter, milk, sugar, flour, cake mix, whatever. Okay. The process happens to be a hand mixer and the baking oven itself. And the output, I end up with a cake with a crater and a bunch of cracks on it. What could have gone wrong here? You could speculate. You could sit here and say, well, maybe I've got the wrong ingredients. Maybe I'm missing an ingredient. Maybe I'm using margarine instead of butter. Maybe I got the wrong quantities. I mixed the wrong quantities. Maybe I use milk instead of cream. Who knows, right? Or you can look at you can also say, well, maybe I didn't mix it properly with the hand mixer. I didn't beat it long enough. Maybe I should have beat for 5 minutes. I only did 3 minutes. The batter was too thick. The oven could be the temperature. It could be, hey, look, I didn't put it in at the right temperature. Maybe I didn't preheat the oven. Maybe I have a defect in the oven where it's reading one temperature and it's really, providing another temperature. Maybe the timing on the oven, maybe it was supposed to be in for 20 minutes and I kept it in for 30 or kept it in for 10, whatever. Okay. All kinds of things that you can surmise here relative to why I have a defective cake. But if you're not looking at those inputs, in this case, all the ingredients, and just looking at the process, you're going to go wrong. Okay. Now, this is a very simple example, but I want to, again, use a simple real life example to show you that you've got to be looking at the whole picture, not just where you found the problem. And let's just say, for example, that I used milk instead of cream, and that's the reason for this defective cake. That's an input. That's an input. So if I'm only focusing on the process, I'm going to make a mistake. Now, we told one of our clients they were focused on the machine, and they said, "Yeah, no, the machine always has a problem. It's a continuous, process." So, and we're trying to get them to think about the inputs, the materials going in. So we asked a simple question: run the machine with no materials, see if you still have the problem. Okay, and guess what? It got their head turned around to say, "Hey, we got to start looking at the inputs, the quality of what's going into this machine. All right, the raw materials that we're using to process the product." Okay, so this input process output is very important, and you got to really think through whether or not any of these things along this chain are in fact your issues. Okay, solutions should be process based. There's an adage with Toyota that says Toyota gets brilliant results with ordinary people running brilliant processes. Okay. So if I have a solution and I'm not baking it into a fundamental process, I'm not doing my job as a problem solver. Okay. Either the process didn't exist or we have to augment one because it wasn't working. Okay. Remember now, there can be no improvement without a standard. Tadashi Ono said that. You cannot tell me I made a mistake if there's no standard in which to measure me by. If you said, Mark, you put the red one in when the blue one should have been in there. How do you know that's a mistake? Well, everybody should know that. Really? Show me the process. There's no process. There's no spec. There's no standard. Okay. So you can't tell me I made a mistake. So without a standard, there can be no improvement because I can't measure myself against what should be. Okay. But remember, your solution should be process based. Similarly, with that, you have to create repeatable, robust standards that are repeatable, where everybody can run this thing. Obviously, with the requisite training, right? But our friend Deming is back again, and he says if you cannot describe what you are doing as a process, you don't know what you're doing. I had a question asked me of a new client one time. They said, "Hey, Mark, our forecasts are always off. We get bad input from the customer, and we really, get blindsided at the last minute. Our SIOP process is broken, and our forecasting is all screwed up. And how does Lean handle that?" I said, "Well, it probably doesn't, unless you could show me your process. Could you give me your process as to how you guys do forecasting and demand management?" Well, let me show you our forecast. No, I didn't ask you to show me your forecast. I asked you to show me the process. Okay. Show me the process. Well, we don't really have it written down. Oh, okay. Then all I can tell you is I can't help you. And unless you want me to help you create the process, then we got something to put our arms around. Now I can get the process to be what it needs to be for an outcome. And I can then come back to you and say, okay, let's put the daily management systems in so this works. And where it doesn't give us the desired output or outcome, we augment the process. Now I get something to change. But if you expect me to figure out what's in your head and what's in the production planner's head and what's in sales head and what's in the inventory people's head and purchasing, good luck with that. I'm not a mind reader. I can't do it. But if I have a process and I bring all those parties together, remember, not just one uh, function that's going to solve this. We bring them all together, we can at least come up with one process that we can implement and improve in the future as need be, right? I've got one thing to change now for everybody. I don't have to worry about what everybody thinks the process is. And that's how you have to think about this as a problem solver. Okay? So if you can't describe what you're doing as a process, you don't know what you're doing. And again, this person, a great guy, he wanted to show me the forecast. That's not the process. I want to see the process. Okay? Okay. You need to test your solutions before doing Yokoten. If you're not familiar with Yokoten, that means spreading best practices. So you come up with a solution that you think can be spread across your company. Okay. Yokoten should be treated as an experiment, number one. If the performance does not improve, the idea is not worth spreading, right? But Yokoten is about adopting and applying, or adapting, I should say, and applying new practices effectively in different contexts, not to just copy them. I can guarantee you, if you come up with a solution that you think could be used in another part of your company, you can't just, you know, copy and paste. You'll have to adapt it to where you're bringing it to. All right. But test your solutions, else you're going to waste a lot of time, cause a lot of damage if you're not careful. Okay. Test your solutions before allowing these ideas to be spread out in the rest of the company. And finally, watch out for collateral damage. Learn to see the forest from the trees. Okay. Case study. Company wanted to slow down their line speed because high line speeds on this automated process were causing all kinds of machine shutdowns and defects. So they figured that the line speed was the issue and thought they had this problem solved. The problem, though, is that the line speed they set it at to get zero, breakdowns in good quality would not meet their takt time to meet customer demand. So on one hand, you solve a problem, or you think you solved a problem, but now you basically created another problem in that you can't meet your customer requirements. Okay. So you've got to look at these solutions not in isolation, but how they affect other areas of the business. All right. And this is a live example. So learning to see the forest from the trees is part of being a critical thinker and a good problem solver. So you always have to ask those questions, almost like a failure mode effect analysis. What could go wrong when we implement this solution? Let's have that discussion. Okay. Finally, our problem solving process is actually a 14-step process, but it follows the plan, do, check, act cycle. Okay. And I would argue that this process, a lot of time is spent in the first couple of parts of this process where we collect and analyze data. Because if we don't do a good job there, we are not going to develop an effective problem statement. Okay. So I just want to reinforce the importance of a good, sound problem statement that's data based. So what I'd like you to think about here, of course, is test all of these adages to your problem solving abilities. Do you do this on a regular basis? All of these different things. Okay, this is more of a mindset thing. Now, the real key here is to actually get the people in your company as they solve problems and learn, that muscle of solving problems to be able to think this way. This is a mindset issue. This is a cultural mindset of how we all think about problems. We've all jumped to conclusions before, thinking we have the answer. We have a lot of confirmation bias, of course, where we are automatically think we know the answer to that problem. And my question is, geez, if you're that smart, why did you have the problem to begin with? Okay, everybody has their notions that here's why the problem exists. Now, you may be right, by the way, but most of the time you're not going to be right. And those people who come to the party saying, I got the answer, okay, or a leader who's 5 levels away from the problem says, I know what you guys need to do. Just go do this. And nobody has the courage to push back on the leader and say, no, we have a process in order to figure this out, Mr. Leader, Mrs. Leader. And we're going to go through that process to make sure we'll certainly test your hypothesis that you think that's the solution. And we'll come back to you and let you know. But we have a process we're going to follow. But just jumping in on somebody's whim, thinking that they know the answer, will get you in a lot of problems. And there's a lot of leaders that confuse activity and quick action for problem solving because they feel as leaders they need to be compelled to act. And taking the time, like Einstein said, I'm going to take 55 minutes to study the data, to study the problem before in 5 minutes to solve it. Okay? That's the key here. And so many people bypass that front part of the problem solving process only to find that they've created more problems, wasted more time, and before you know it, nobody wants to be involved in problem solving anymore. So be careful. Okay, just be careful as you go through this. These are some of the critical thinking skill sets you need to develop, and some of them may be very obvious to you. Some of them maybe not, but try to institutionalize these. I would start off every problem solving event with this presentation. Okay, to say, hey, look, here are the things that we have to keep in the back of our mind. The obvious may not be obvious, and that's something you got to think about. Okay? All right, episode 64. Do you have a problem-solving mindset? Are you a critical thinker? Okay? Hopefully you are. And if you're not, you can develop that skill. All right? Any questions? Get back to me, Mark at lean911.com. Comments, questions, anything I missed? I'm sure I did. Love to hear about it. Maybe you can add it in on another episode. Thanks, everybody. Stay lean. Thanks for listening to the Lean 911 podcast. I'll be happy to address your questions or feedback on future episodes. Email me at mark@lean911.com. You can check out our other episodes by visiting our website at lean911.com, our YouTube channel, wherever you listen to podcasts. This is your host, Mark DeLuzio. Thanks for listening.